I need to learn GraphQL, so I thought, what better way to do that than by reading the spec? Over here on the left, I have my notes, and over here on the right, I have the spec that I've opened up. And let's get started. Licensing conformance. A conforming implementation of GraphQL must fulfill all normative requirements. Conformance requirements are described in this document via both descriptive assertions and keywords with clearly defined meanings. The keywords must not, required, shall not, should not, recommended, may, and optional in the normative portions of this document are to be interpreted as described in IETF RFC 2119. These keywords may appear in lowercase and still retain their meaning unless explicitly declared as non-normative. A conforming implementation of GraphQL may provide additional functionality, but must not, where explicitly disallowed, or would otherwise result in non-conformance. So if we go look at these things, what do those words mean? We must, this word, or the terms required or shall, mean that the definition is an absolute requirement of the specification. Must not, should not. Okay, yeah, that makes sense. Conforming algorithms. Algorithm steps phrased in imperative grammar, e.g. return the result of a calling resolver, are to be interpreted the same level of requirement as the algorithm as it is contained within. Any algorithm referenced within an algorithm step, e.g. let completed result be the result of calling complete value, which is to say completed result equals complete value, parentheses, is to be interpreted as having at least the same level of requirements as the algorithm containing that step. That makes sense. Conformance requirements expressed as algorithms can be fulfilled by an implementation of the specification in any way, as long as the perceived result is equivalent. Algorithms described in this document are written to be easy to understand. Implementers are encouraged to include equivalent but optimized implementations. Sure. See Appendix A for more details, blah, blah, blah. Okay. Non-normative portions. All kinds of this document are normative except for portions explicitly declared as non-normative. What does normative even mean? Relating to or dealing with norms. Well, yeah. Okay, I guess that is to say you take them as gospel unless you don't. Examples in this document are non-normative and are presented to aid the understanding of introduced concepts and behavior of normative portions of the specification. Sure, so examples are non-normative. Got it. They look like this. There's another one, and here's another one. All right, table of contents, love it. We got some stuff to go through. All right, overview. GraphQL is a query language designed to build client applications by providing an intuitive and flexible syntax and system for describing their data and requirements. So it's a query language designed to build the client applications describing their data requirements. All right, that's pretty good. That's a good definition. Query language used to build client applications. Describe data requirements. Love it. For example, this GraphQL request will receive the name of the user with ID 4 from the Facebook implementation of GraphQL. So we're querying for a user with ID 4, and we're looking for the field name, which produces the following result. In JSON, we have a user with a name of Mark Zuckerberg. Wonder who that is. GraphQL is not a programming language, capable of arbitrary computation, but is instead a language used to make requests to application services that have capabilities defined in the specification. Defines capabilities, does not do computation. GraphQL does not mandate a particular programming language or storage system for application services that implement it. Instead, application services take their capabilities and map them to a uniform language, type system, and philosophy that GraphQL encodes. Blah, 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 blah. Okay, we have some design principles. Oh, that's useful. All right. So where are we? We're in the overview section, and we're looking at some design design principles. Product-centric. GraphQL is unapologetically driven by the requirements of views and the front-end engineers that write them. GraphQL starts with their way of thinking and requirements and builds the language and runtime necessary to enable that. Starts from a front-end perspective. Hierarchical. Most product development today involves the creation and manipulation of view hierarchies to achieve congruence with the structure of these applications. GraphQL is structured hierarchically. The request is shaped just like the data in the response. It is a natural way for clients to describe data requirements. Okay, so it's hierarchical in the same way that React is. Sure, that makes sense. Although maybe that comparison to React is not quite apt. Most product development today involves the creation and manipulation of view hierarchies to achieve congruence with the structure of these applications. The GraphQL request itself is structured hierarchically. I don't know if I buy that. Is that why it's hierarchical? Because it fits the views you're... Maybe. I don't know. I'm not sure about that. Strong typing. Yeah. Strongly typed. Love it. Client-specified response. Through its type system, a GraphQL service publishes the capabilities that its clients are allowed to consume. It is the client that is responsible for specifying exactly how it will consume these published capabilities. These requests are specified at field-level granularity. In the majority of client-server applications written without GraphQL, the service determines the shape of the data. GraphQL response contains exactly what the client asks for and no more. Okay, so client-focused. Only return what the client wants. Introspective. GraphQL is introspective. A GraphQL service type system can be queryable by the GraphQL language itself, as will be described in the specification. GraphQL introspection serves as a powerful platform, blah, blah, blah. So which is to say, you can inspect the type system represented, exposed by GraphQL? Sure. Powerful and productive, blah, blah, blah. Quality tools, blah, blah, blah. Following formula, blah, blah, blah. Okay. On to the language. Clients use the GraphQL query language to make requests in the GraphQL service. Ooh, you know, let's make some vocabulary. So we have like, got like a query language. Language that describes a query, I guess. Sure. Document syntactic grammar. Now, where are we going? Clients use service. GraphQL service. Something that can respond to GraphQL queries. GraphQL requests. Yeah. Refer to these requests sources as documents. Document may contain operation. Clients use the GraphQL query language to make requests to a GraphQL service. We refer to these requests sources as documents. I wonder what that means exactly. Not sure if I can define documents yet. A document may contain operations. Operation, which is a query, mutation, or subscription. Didn't know I could do subscription, as well as fragments. Common unit of composition allowing for data requirement reuse. A unit of composition allowing for reuse. Okay. Oh, here we go. A GraphQL document is defined as a syntactic grammar where terminal symbols are tokens, invisible lexical units. These tokens are defined in a lexical grammar which matches patterns of source characters. Don't know what that means. In this document, syntactic grammar productions are distinguished with a colon, while lexical grammar productions are distinguished with a double colon. Oh, of course, that all makes sense. Not. Okay. What? All right, so I guess we have some other things. These token graphs define a syntactic grammar where terminal symbols are tokens. That is so vague as to be useless. These tokens are defined in a lexical grammar which matches patterns of source characters. Okay. This document, syntactic grammar productions are distinguished with a colon, while lexical grammar productions are distinguished with a double colon. Syntactic grammar. Well, who the hell knows what that means? Syntactic grammar. Not sure. And what else are we looking at? Lexical grammar. Grammar. Oh boy, I'm going to make a lot of spelling mistakes here. Graphql document. Find a syntactic grammar terms. All right, we'll just like paste that in there. We'll update it as we go. The source text of a GraphQL document must be a sequence of source character. Oh no, I didn't want to do that. The character sequence must be described by a sequence of token and ignored lexical grammars. The lexical token sequence emitting ignored must be described by a single document syntactic grammar. Oh, okay. So we're like getting into language stuff, which I don't really understand, but is really useful if you're implementing this stuff. Okay. The source text of a GraphQL document. This is to say something that like contains queries and mutations and subscriptions must be a sequence of source character. We'll put that in there anyways. Source character. Must be sequence. The character sequence must be described by a sequence of token ignored the lexical token sequence emitting ignored must be described by a single document syntactic grammar. Okay, interesting. Yeah, will this even make any sense later? I don't know, but we'll write it down. See Appendix A for more information about the lexical and syntactic grammar and other notational conventions used throughout this document. Yeah, let's take a look. All right, so we're in language. If we go to source character, what the heck does that mean? GraphQL documents are expressed as a sequence of Unicode code points, informally referred to as characters. Oh, what the heck is a Unicode code point? Oh, of course, yeah. A code point is a unique position in a quantized n-dimensional space that has been assigned a semantic meaning. A DOI, in other words, a code point is a particular position in a table. Okay, that's much easier to think about, where the position has been assigned a meaning. Okay, that's pretty simple. The table has discrete positions and may be one-dimensional. Oh, three-dimensional. Oh, yeah, okay. Code points are used. Okay, so it's just like it's just a character. Yeah. All right. So like this is like the Unicode character something, and it means some other thing. Like this could be the character for a period, and it means period. Who knows? Unicode code points through this. However, with few exceptions, most of GraphQL is expressed only in the original non-control ASCII range, so as to be widely compatible with as many existing tools, languages, and serialization formats as possible to avoid display issues in text editors and source control. Non-ASCII Unicode characters may appear freely and within string value and comment portions of GraphQL, which is to say like emojis and stuff. So if I look this up, like what the heck is this? It's a tab. Okay. What about this one? End of line. Sweet. Love it. Carriage return. Oh, this one's a big one. Okay. That's got to be something special. Ooh, a space. Space separator. I guess it's just the space. Oh yeah, really exciting. Love it. Source character. All right, so we have like a tab, end of line, carriage, return. What is the difference between end of line and carriage return? I don't know. Space. If I look this up, what is it? End of line. So that's that's what I'd call a new line versus R. What is the difference? Control character, mechanism used to reset a device position to the beginning line of text is closely associated to the line feed in new line concepts, although be considered separately in its own right. Okay. Yeah, where does carriage return come from? Really, the term carriage return referred to a mechanism or lever on a typewriter. Oh, it's this thing. What does that do? I never used a typewriter. For machines where the type element was fixed and the paper held a moving carriage, this lever was on the left attached to the moving carriage and operated after typing a line of text to cause the carriage to return to the far right. So the type element would be aligned to the left side of the paper. Oh, so you're like typing and the paper moves, and so you're typing, and the paper is going to move left or right. No, it's going to move left. The paper is going to move to the left. The carriage is going to move to the left, and then you like hit this bar over here, and it's going to ding, do the little ding thing, move the carriage all the way back to the right. Fascinating. Okay, so like tell the typewriter to go back to the other line. Why is that different than a new line? New line. Many computer character loaded line feed. Line feed. What is a line feed? Really going down rabbit hole here. To signal the end of a line of text, but other characters are also used as its function. See new line. Others use it only as a paragraph break. Some standards which introduce. Wow. Okay, so it's an anachronism, which I think is the right word here. Comes from typewriters. Who really cares? We got to support it because typewriters. Makes sense. All right. Where was I? Oh, yeah, we were at language. Token. Oh, let's take a look at token. Graphql document is comprised of several different types of indivisible lexical tokens defined here in a lexical grammar by patterns of source Unicode characters. Lexical tokens may be separated by ignored tokens. Tokens are later used as terminal symbols in Graphql. So okay, what's a punctuator? Name, start, name, continue, letter. All right, so we're just like recursively defining these things. The letter. Ooh, look at highlights. Oh, that's nice. What is this? Is it an underscore? Yeah. Oh, and we got the dot dot. Oh, I see kind of where that comes in. Interesting. So one of. Yeah. Okay, that's cool. Name gonna need to look ahead. Oh, what does this symbol mean? I don't remember. Is that not in the set of name continue? Could be wrong. Interesting. Okay, so this is like stuff we care about. Interesting pieces. Interesting text. Interesting everyday text. Letters, numbers, punctuation, etc. Okay. Ignored tokens. Yeah. Are used to improve readability and provide separation between lexical tokens, but are otherwise inconsiderable and aren't referenced in syntactical grammar productions. Any amount of ignored may be no ignored reading as a source document are significant. However, source character, which appear in ignored, may also appear within a lexical token in a significant way. For example, a string value may contain whitespace characters. Yep. No ignored may appear within a token. For example, no whitespace characters are permitted between the characters, finding a float value. Huh. I kind of get that. I think this is just a really verbose way of describing whitespace, basically. What is a Unicode bomb? Byte order mark. Whoa, interesting. I'm learning so much. Comment, comma. Interesting. So you can have multiple commas? That's wild. What a world we live in. Anything else? Token, ignored, single document. If we look at this. Ooh, interesting. Oh, now we're getting into it. A document is a definite. Well, what do these dots mean again? In this document, syntactic grammar productions are distinguished with a colon, while lexical grammar productions are distinguished with a double colon. What the heck is the difference between a syntactical grammar and a lexical grammar? What if I search for this? Not got a lot of. Find is a syntactical grammar. Let's Google it. Versus lexical grammar. Oh yeah, my old friend Stack Overflow. Whatever. Skip to the answer. More expansive definition of syntax would be the set of all ordered combination of symbols which form a correct document in the given language. Thus, syntactic grammar can be similarly described as a portion of the language grammar that describes how various tokens can be ordered. To form meaningful phrases. Okay, so it's like a high level, how do we put words together? How do we put tokens together? Force this phone's back. Definition of lexical grammar. So allow me to highlight the major difference. Lexical grammar describes the structure of the lexicon, that is, every token or word used in a language. Syntactical grammar describes how phrases and documents are formed into these tokens. From these tokens. Okay, I kind of get that. So syntactic grammar is like higher level, more abstracted. Lexical grammar is like the lower level junk. So if we go to document again, we're looking at higher level is single colon, lower level is double colon. If we look at document, yeah, that is a single colon. But if we like look at the names and stuff, these are lower. Well, you know, I gotta say, I don't really understand exactly what the distinction is, but okay. Maybe it's the fact that a document is sort of a proper noun within the GraphQL pantheon. This is like a higher level rule set for how a language works. This is like a lower level rule set for how language works. All right, so looking at document. GraphQL document describes a complete file or request string operated on by a GraphQL service or client. Complete file or request string operated on by GraphQL. A document contains multiple definitions, either executable or representative of a GraphQL type system. Interesting. Documents are only executable by a GraphQL service if they are executable document and contain at least one operation definition. A document which contains type system definition or extension, must not be executed. GraphQL execution services which receive a document containing these should return a descriptive error. GraphQL services which only seek to execute GraphQL requests and are and not construct a new GraphQL schema may choose to only permit executable documents. Okay. I don't think we need these. Document. Where is my document? May contain operations. Yep, that's syntactic grammar where terminal symbols are tokens. That still doesn't make sense to me. Terminal symbols are tokens, indivisible. Who cares about that? Yeah, describes a complete file request string operated on by a GraphQL service or client. Love it. Can contain multiple definitions, either executable or representative of a GraphQL system. Okay, so you can like write GraphQL queries, which are executable. You can write those in documents. And you can like define the GraphQL type system also in documents. That's kind of interesting. Never knew that. Operation definition, execute request, documents do not contain, still be parsed and validated to allow client to many GraphQL users. The document contains only one operation. That operation may be unnamed. Oh, that's useful. If a document contains one operation, that operation may be unnamed. Unnamed. There we go. If that operation is a query without variables or directives, then it may also be represented in the shorthand form, omitting both the query keyword as well as the operation name. Now, if that single operation is a query without variables or directives, you can omit the query keyword as well as the operation name. And the operation name. I think the operation name would be just query. Is that? No, that's not true. It'd be like query. Kind of like this. Actually, it doesn't actually define the operation name at all. Interesting. All right, back to the language. Wow, we're making so much progress here. Lexical analysis and syntactic parse. We looked at document. Was there anything else in there? If a document contains only one operation, that operation may be named. Otherwise, multiple operations. Each operation must be named. When submitting a document with multiple operations to a GraphQL service, the name of the desired operation to be executed must also be provided. Wait, what? When submitting a document with multiple operations to a GraphQL service, the name of the desired operation to be executed must also be provided. Oh, so you can like submit a document with multiple operations and you don't have to execute all of them. That's interesting. Why would you ever do that? I don't know. Huh. Fascinating. Go back to the language. We're not even at section 2.1 yet. Okay, lexical analysis and syntactic parse. Man, we got some great vocab. The source text of a GraphQL document is first converted into a sequence of lexical tokens. And we defined a token as like everyday text, and ignored tokens, which is like white space basically. Yeah. The source text is scanned from left to right repeatedly, taking the next possible sequence of code points allowed by the lexical grammar productions as the next token, which is to say it's going to read the characters that are allowed. This sequence of lexical tokens are then scanned from left to right to produce an abstract syntax tree according to the document's syntactical grammar. Yeah. Lexical grammar productions in this document use look-ahead restrictions to remove ambiguity and ensure a single valid lexical analysis. A lexical token is only valid if not followed by a character in its look-ahead restriction. Interesting. Is that to say... Okay, I can't click on that. Is that to say, like, if there's a token that's being scanned right now, the parser will sort of look ahead of that token, make sure everything else after it is also valid or something? I don't know. Maybe it's just a fancy way of saying it'll be smart. For example, an int value has the restriction. Look ahead. What does this symbol mean? Can I copy it? math symbol not in set. Math symbol E with slash. Kind of. No. Is an element of. So not an element of. Yep, I think that tracks. For example, an int value has the restriction that its look ahead cannot be a digit. So cannot be followed by a digit. Int value. Wait, does that make sense? That doesn't make sense to me. Integer part, look ahead, not be. Integer part is a negative sign, sure. Non-zero digit, a digit. But non-zero. Look ahead. So is that to say like an int value? Oh, you can't say like 6 space 6. That would be invalid. Okay, I think that makes sense. Because like when it's talking about these things, it's talking about tokens, which don't have anything to do with white space, right? The white space is like stripped out. Okay, all right. Because of this, the sequence 1, 2, 3 cannot represent the tokens 1, 12, and 3, since 12 is followed by the digit 3, and so must only represent, wait, what? Cannot represent the tokens 1, 12, followed by the digit 3, and so must only represent the single token. Use white space or other ignored between characters to represent multiple tokens. Wait, what? I don't understand that. I think this is something really basic. Maximal munch, longest possible match. However, some lookout restrictions include additional constraints. I don't really understand how this maps to this, but yeah, basically, when you think you got a number that says 1, 2, 3, it's the number 1, 2, it's 123 versus 12 and 3 as separate tokens. Sure, that makes sense. Oh man, we got a long way to go here. Source text. Graphql documents are expressed as a sequence of Unicode code points, which is to say characters, formerly referred to as, oh, here we go, characters through most of the specification. However, with a few exceptions, most of GraphQL is expressed only in the original non-control ASCII range. Most of GraphQL is so as to be widely compatible with many existing tools languages, blah, blah, blah. Yeah, non-ASCII Unicode characters may appear freely within string value and comment. Right. That makes sense. Source character. What? These are like all the like carriage returns, etc. Yeah. Why? Okay, whatever. Unicode byte order mark. The byte order mark is a special Unicode character which may appear at the beginning of a file containing Unicode, which programs may use to determine the fact that the text stream is Unicode, which Indianness the text stream is in which of several Unicode encodings to interpret. Okay, so it's like a marker. Got it? White space, horizontal tab, or a space. White space is used to improve legibility, source text, blah, 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 blah. Blah, blah, blah. Line terminator, new line, carriage return. Another kind of carriage return. More new lines. I don't know why that's significant. White space, line terminators, blah, blah, blah. Any error reporting which presents a line terminator. Line terminator to produce the line number. Comments. Here's the comment character. May contain a source character, but not a line terminator. Sure, makes sense. Anytime you have a new line, the comment is over. GraphQL source documents may contain single line comments starting with the hash marker. A comment may contain, I'll write this down. Comments. Comments are signified with this. Sure. Comment may contain any unicode except line terminator, so a comment always consists of all code points starting with the blah person. Comments are ignored. Like white space, it may appear after any token or before a line terminator. Yeah. Insignificant commas. Similar to white space and line terminators, commas are used to improve the legibility of source text, insert lexical tokens, but are otherwise syntactically and semantically insignificant. Oh, interesting. Non-significant comma characters ensure the absence or presence of comma does not meaningfully determine syntax. This can be a common user error in other languages and allows for stylized use. Trailing commas or line terminators as list eliminators. Interesting. Okay, so that's like a way to commas. Commas are ignored, used as list delimiters. Yeah, interesting. That kind of doesn't make sense to me. How do you define a list without commas? Because the commas are ignored? I don't know. I don't think it matters too much. Lexical tokens. Punctuator name. Yep. Graphql document is composed of several kinds of indivisible lexical tokens defined here in lexical grammar by patterns of source Unicode characters. Lexical tokens may be separated by ignored tokens. Tokens are later used as terminal symbols in Graphql syntactic grammar rules. So this is like stuff, important stuff. Yeah. Ignored tokens. We looked at this. They're ignored. That's white space. Punctuators. We looked at this. Graphql document and punctuation in order to describe structure. Graphql is a data description language and not a programming language. Therefore, Graphql lacks the punctuation often used to describe mathematical expressions. Sure, makes sense. A name. A name start, name continue. List optional. Look ahead. I wish I really understand what the heck look ahead was talking about. I kind of get it. The look ahead does not equal name continue, or does not contain any name continues. Interesting. Name continue, letter, digit. Yeah. I don't know why that's significant. Graphql documents are full of named things, operation fields, argument type, directive, fragments, and variables. All names must follow the same grammatical form. Names in GraphQL are case sensitive. That is to say, name, name, and name all refer to different names. Underscores are significant, which means other name and other name are two different names. A name must not be followed by a name continue. In other words, a name token is always the longest possible valid sequence. Oh. The source characters A1 cannot be interpreted as two tokens since A is followed by the name continue 1. Yeah, okay, so like what it's saying is just name start is like the first letter and name continue is any letter after that. No, look ahead. I don't really get that. That's okay. This is like really breaking down basic stuff into very precise language. Names in GraphQL are limited to Latin ASCII. Any name within GraphQL system should not start with 2 underscores. That's reserved. Document. All right, we made it to 2.2. Nice. Document. Document is a definition, which is a list, I guess, or can be a list of definitions. A definition is either executable or type system definition or extension. Executable document. Interesting definition. Where does this come from? Interesting. A GraphQL document describes a complete file or request string operated on by a GraphQL service or client. A document contains multiple definitions, either executable or representative of a GraphQL type system. Okay, we read this already. Documents are only executable by GraphQL service. GraphQL services which only seek to execute documents. We read this already. Okay. Operation. Operations. So how does operation definition, does that come in here? Yeah, it does. So executable definition kind of confused about that, the difference between these two things. Anyways, executable, yeah, like why is there an executable document and a definition? That is a document. Maybe this is like a shorthand thing. Executable definition, yeah. Operation definition. Or a fragment definition. Okay, we'll look at fragments in a moment. So what's an operation? There are three types of operations that GraphQL models: a query, which is a read-only fetch; mutation, a write followed by a fetch; or a subscription, a long-lived request that fetches data in response to source events. Solid. Okay, so we have operations. We got the query, read-only. Can I just copy this? Heck yeah. Love it. Each operation is represented by an optional operation name and a selection set. Oh, the operation name is optional? Interesting. And a selection set. Okay, for example, this mutation operation might like a story and then retrieve the new number of likes. So it's going to like a story. It's going to get the story like count after it does that. Sure. Okay. Query shorthand. If a document contains only one operation and that operation is a query which defines no variables and contains no directives, then that operation may be represented in a shorthand form which omits the query keyword. So you can do shorthand. You can do a shorthand notation if you are making a single query, making or representing a single in a document, and that query does not take, what do we call it, variables? Not parameters, not arguments, but variables. Sweet. All right. Selection set. Yeah, all right. So queries and a selection. Where did I just see selection set? Yeah. What's a selection set? I assume it's like this stuff. Yeah, look, it's that stuff. All right. Operations. So what did we just say? They contain operation name. Operations are made up of a, no, that's not what I wanted. Name and a selection set. Oh, come on. Almost. There we go. And a name, an optional operation name. Yeah. Each operation represented. Sure. So we can have like something like looks like this, where the name is like story, and the selection set is all the stuff in the brackets, curly braces below the name. Yeah. Okay, that makes sense. It's like this stuff I'm selecting is a story and a like count. Sure. Selection set. We got some brackets, and then inside of here we have a list. Yeah. So we have like here we could do one thing, and we could do like followers or something else, like a name. I don't know. Sure, makes sense. Got it. An operation selects the set of information it needs and will retrieve data exactly. Will retrieve exactly that information and nothing more, avoiding overfetching and underfetching data. An operation selects the set of information it needs. So selection can be a field, a fragment spread, or an inline fragment. So I think I have an idea of what a field is. This is like anything like this. We'll get into that later. A fragment spread. Yes, this is like we can define a fragment. Do we have like friends fields? Yeah, we can define a fragment and then like spread that out, sort of like the splat operator or the spread operator in JavaScript. Yeah, and it'll like expand. It'll say ID name, profile pic, size 50, put it in there. Sweet, that's pretty cool. And an inline fragment, What the heck is that? Fragments can be defined in line with a selection set. This is done to conditionally include fields based on their runtime type. This feature of standard fragment inclusion was demonstrated in the query fragment typing example. We could accomplish the same thing with inline fragments. So we have inline fragment typing, profiles, handles, Zuck or Coca-Cola, handle. Oh. Okay, so we can like retrieve a handle on user profiles. So we're asking, we have a query that we have named, and we're looking for profiles, and we're going to return their handle. And if the profile is for a user, then we're going to return these things. And if the profile is for a page, we're going to return these things. Cool, got it. All right, interesting. That makes sense. Okay. All right, a selection. I'm going to do names. We have selection set coming up after this. Arguments, field alias, fragments. I'll put it here. Contain a field, a fragment spread, e.g. something where we do fragment name, or, there we go, an inline fragment, which, I don't know, kind of complicated to put an example in there, so I'll skip it. An operation selects the information it needs. In this query operation, the ID, first name, and last name fields form a selection set. Selection sets may also contain fragment references. Yes, cool, great, love it. Okay, so fields, 2.3, 2.4, 2.5. Yeah, we'll do this. Operation means name, selection set. Yeah. Fields. I do something like this. Yeah. Having trouble thinking about how to organize my notes. Shorthand, we'll just say names and selection sets. Yeah, then this will be fields. Yeah, fields. A selection set is primarily composed of fields. A field describes one discrete piece of information available to request within a selection set. Oh, that's a great description. Some fields describe complex data or relationships to other data. In order to further explore this data, a field may itself contain a selection set, allowing for deeply nested requests. Can contain a selection set, allowing you to nest requests recursively. Yeah. All GraphQL operations must specify their selections down to fields with return scalar values to ensure an unambiguously shaped response. Sure. So we can't like, I'm going to like select, well, maybe there's an example. We'll see. For example, this operation selects fields of complex data and relationships down to scalar values. Yeah, you got to like end, you can't just say birthday, because birthday is not a scalar. It's like an object that contains other things. So if you were to just say birthday, it wouldn't know, like, do you want a month? Do you want a day? Do you want both? So you got to specify those things. Makes sense. Fields, when, describing a, what are we going to talk about this? A graph an operation, you must specify selection sets down to scalar values. You can't just select a field that represents, e.g., a graph object, other fields. Yeah. Fields in the top-level selection set of an operation often represent some information that is globally accessible to your application in its current viewer. Some typical examples of these top fields include references to a current logged-in user, viewer, or accessing certain types of data referenced by a unique identifier. Me can represent the current login. Yep. User represents one of the many users in the graph data referred to by a unique identifier. Yeah. So we have like top-level fields basically that are accessible by anybody who's logged in or anybody who has access to the GraphQL API. Sure. And I suppose the values of these things, depend on the logged in user, for example. Okay, arguments, const, it goes in parentheses. Yep, love it. Name, value. Yeah, sure. And value, it could be a variable. Yeah, cool, interesting. That's too far. Go back to arguments. Fields are conceptually functions which return values. Sure. And occasionally accept arguments which alter their behavior. These arguments often map directly to function arguments within a GraphQL services implementation. Sure. In this example, we want to query a specific user requested by the ID argument and the profile picture of a specific size. So we say, I want user ID 4 and profile pic of size 100. Many arguments can exist for a given field. Yep, sure, we can do that. Arguments are unordered. Yep. Sure. Fields can take arguments specified like field name value, something like that. Name to value. The order doesn't matter. Sweet. Anything else? Yeah. Field alias. Interesting. Didn't know. What is this? By default, a field response key in the response object will use that field's name. However, you can define a different response key by specifying an alias. In this example, we can fetch 2 profile pictures of different sizes and ensure the resulting response object will not have duplicate keys. Okay, so you can like rename the values that are returned. That's cool. I wonder how this is handled on the back end. I guess it would just call this resolver, this field, twice with different arguments. That's interesting. Fields can be aliased so that have different names in the resulting data that is returned. So e.g., you got like a user for, I'll just copy this. That's a great example. Love this example. Holy cow. I love it. Oh my gosh, that is just the best example I've ever seen. All right, which return this result. Yeah, cool. Hey, what about this? Oh, that doesn't go anywhere. I can't get a 64 by 64 pic of Mark Zuckerberg. That'd be pretty cool. But who is that guy? Why does he keep getting mentioned? The fields at the top level in operation can also be given an alias. Oh, that's interesting. Yeah, that makes sense. Yeah, that makes sense. Sure. I feel like you wouldn't want to do this a whole lot, but because it'd be kind of confusing when you do. You'd really probably want to have a good reason. Ooh, fragments. All right. Fragments. Yeah. So you can have a fragment spread, which is like a fragment name and directives. I don't know what a directive is. Fragment definition. You say fragment name, type condition, directives, selection set. Yep. Fragment name, but not on. Interesting. So you can't name a fragment on. Sure. I don't know what the type condition. What is a directive? Okay. Never seen this before. Cool. We'll get to that. Fragments are the primary unit of composition within GraphQL. Fragments allow for the reuse of common repeated selections of fields, reducing duplicated text in the document. Inline fragments can be used directly within a selection to condition upon a type condition when querying against an interface or union. Yeah, okay. For example, if we wanted to fetch some common information about mutual friends as well as friends of some user, we could do, so we're going to grab the user and we're going to get their friends, first 10, and then we're going to say mutual friends. Oh, is this like sort of from the reference of logged in user who is not user 4? We're going to say, give me the first 10 friends of user 4 and then find the first 10 mutual friends that I share with user 4. Sure. And we notice we have some fields here that are the same. We can extract those to a fragment in the same document and then use that fragment with the, what do we call this? Fragment spread operator. Fragment name, directives. I'm so curious what that means. Cool. Fragments are consumed by using the spread operator. Nice. All fields selected by the fragment will be added to the field selection at the same level as the fragment invocation. This happens through multiple levels of fragment spreads. For example, with nested fragments, we have some friends, field friends. Yeah, so it'll just like spread all this stuff. So it'll be like ID, name, and then profile pic. And then in here, it'll be ID, name, profile pic. Yeah. Operations, no fragments, with nested fragments, all look the same. Yeah, okay, I'm into it. Okay, well, I mean, I think I knew all that, but let's write it down. Fragments define units of reuse within GraphQL. You define them like so, or we have like a fragment name. And then you just put some fields on here. Oh, on user. I don't know what on exactly means. I'm curious to know. Fragment spread, fragment definition, type condition, directives. Is that a directive? Is it on? No, it should be type condition. I don't know. I'm sure we'll learn about that later. ID, name, or whatever. Cool, love it. You use them with the spread operator like so. Query, my query, get users. You say users first 10 or 5, and we say user info. Yeah, nice. I want like a photo. Sure. Sweet. Hey, look at this, a type condition. On, name type. And so that comes into play here. Okay. Yeah. Ah, so this is like here's the on, and then here is the named type. Interesting. What is a name type? Name type is just a name. Graphql describes the types of data expected by arguments and variables. The input types may be lists of another input type or a non-null variant of any other input type. Interesting. Okay, I kind of get that. I think that's just to say the type name. Fragments must specify the type they apply to. I never knew that. Interesting. Fragments must specify the type they apply to. I guess I always assumed that you didn't have to specify one of those. Like you could specify a fragment that could be used at the top level. But does that even make sense? I don't know. I think it does. Interesting. Okay, but they have to apply to some type. Sure. Fragments must specify the type that they apply to. In this example, friend fields can be used in the context of querying a user. Fragments cannot be specified on any input value. Input, what does that mean exactly? I don't know. Fragments can be specified on object types, interfaces, and unions. Cannot be specified on any input value. I don't even know how that would work. Sure. Okay. Selections within fragments only return values when the concrete type of the object it is operating on matches the type of the fragments. Selections within fragments only return values when the concrete type of the object is operating on matches. Yeah, so that is to say, you can define a fragment on one object, and if you try to use it in a query that returns another type of object, the fragment just like won't do anything, basically. Okay, for example, in this operation, using the Facebook data models, we have a fragment here, user fragment, and a page fragment. We're fetching profiles that have a handle, a user, and a page. So these, like the user fragment will only grab these things when the profile being returned is a user, and the page fragment will only be executed and return these things if the thing it's returning is a page. Sure. Profiles root field returns a list where each element could be a page or user when the object in the profiles field returns result is user. Friends will be present. Yeah. Yep. Cool. That's interesting. Fragments specify the type they apply to. If how do I describe that succinctly? You request data that could be many types. The fragment only operate on the type it is. What do we take on name type? Specified to? You specify a fragment type with the on keyword. Cool. Inline fragments. How far are we? We're making our way through the language portion. Yeah, we're maybe 20% of the way through. Oh boy. Inline fragment. So type condition, directives, selection set. So this can be like, yeah, so there's no name, but then we do on, like user, and then something, whatever the heck directives is, and then selection set, which is like everything in the brackets. Cool. Fragments can be defined in line with a selection set. This is done to conditionally include fields based on their runtime type. This feature of standard fragment inclusion was demonstrated in the query fragment typing example. We could accomplish the same thing using inline fragments. Yep. Inline fragments may also be used to imply a directive to a group of fields. Oh boy, I'm getting into directives. If the type condition is omitted, an inline fragment is considered to be of the same type as the enclosing context. Huh, that's a little rich for my blood. I don't know what a directive is. Let's just skip that for now. I'm sure we'll get there at some point. In fact, we will. You can specify a fragment inline it's basically the same thing as using the spread operator, except you don't write the fragment name. Sweet. Oh God. Oh, there's so much. Input value. Okay. We can have a variable or any of the types that we see there. Enum list object. I don't know what question mark const means. Field and directive arguments accept input values of various little primitives. Input values can be scalars, enumeration values, lists, or input objects. If not defined as constant, for example, in default value, input values can be specified as a variable. Lists and input objects may also contain variables unless defined to be constant. What is a default value? What does that mean? Graphql operation can be parameterized with variables, maximizing reuse and avoiding costly string building in clients at runtime. If not defined as constant, for example, default, a variable can be supplied for an input value. Yeah. Variables must be defined at the top of an operation and are in scope throughout the execution of that operation. Values for those variables are provided to a GraphQL service as part of a request, so they may be substituted during execution. Let me read that again. I blanked out. Variables must be defined at the top of an operation and are in scope throughout the execution of that operation. Top of an operation and are in scope throughout the execution. Yeah, sure. Makes sense. Values for those variables are provided to a GraphQL service as part of a request. Maybe substituted during execution. I guess I get that. Sure, they're just variables. Yeah. In this example, we want to fetch a profile picture size based on the size of a particular device. Device pic size. We pass that in there. Providing JSON for the variables. Sure. Okay, that makes sense. Oh, a default value. Oh, we could probably does it talk about? No, it doesn't. We could probably say device pic size : int equals something, and then you're good to go. Or maybe that's a default value. I don't know. Yeah. Int. An int value specified without a decimal point. Int value must be followed by digit. Int value must be followed by its name start. Okay, I'm going to skip through these probably. We got floats, booleans, strings, block strings. Oh, that's cool. I didn't know you could use block strings. So say this is it this level? I think so. Yeah, fields, operation, input values. We got int, float, boolean, string, null, enum, list, object, and then we have a variable. Yeah. Blah, 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 strings, escape characters. If you program, you already know all this stuff. Null. Sure. Interesting. So using null and not using null actually mean different things? Immediately different ways. I don't know. Same method. Possible by either providing value or not. I mean, wait, these two words may be interpreted differently. I guess they could be. I don't know any system that would interpret them differently, but sure. Enums, name, but not true or false or null. Yeah, cool, makes sense. Lists, brackets, got it. Input object values. Input object literal values are unordered lists of key inputs, values, room between curly braces. Yeah, just like a JSON object, sweet. Object literals, yep, makes sense. Input object fields are unordered, yep, cool. Variables. Graphql operation that can be parameterized with variables, maximizing reuse and avoiding costly string building in clients at runtime. Oh yeah, I already read this. I don't understand costly string building in clients. Parameterized. I don't understand what that's talking about, why it would be costly. Whatever. If not defined as constant, blah, blah, blah. Variables, nice to define it. Yep, we already read that. Yeah, here's a variable here. Variable used within fragments. Variables have a global scope within a given operation, so a variable can be used within a fragment must be declared in any top-level operation that transitively consumes the fragment. If a variable is referenced in a fragment and is included by an operation that does not define that variable, that operation is invalid. Okay, so with fragments, variables have a global scope. But a given operation variable used in the fragment must be declared in any top-level operation that transitively consumes that fragment. Yeah, so like if you're going to use a fragment that uses a variable, you need to make sure to declare that variable at the thing that is including the fragment all the way up to the root node in the like GraphQL tree, the query. Makes sense. That's pretty good. I'm gonna write that down. Input values, variables. You can declare variables on a operation. If a fragment uses a variable, the root node that event transitively includes the fragment must make sure to declare variable. I wish variable definitions. We have a variable $, name. Yeah. Variable definitions. Variable type, default value. I wish it gave more of an example for that. I don't know. I'm always confused by this. Like, I don't really get. Yeah, I wish I had a better definition of this. Like, where does it get? Although, actually, if I search for the word variable, we will find this being used somewhere. As an input value. So if I go look here. Oh, wait, no, that's not quite right. It's being used, as an input value here, right? So this could be like a string or an int or whatever, but actually it's a variable. Sure, that makes sense. Where do we do a variable definition? Operation, Operation type, so query, name, fetch users, and then variable definitions, which is the parenthesis stuff goes inside of there. Directives, yeah, selection set. Okay, all right, I'm into it. Okay. Yep. Default value. Yeah, that's just a variable definition is variable type, default value, and directives. So default value is like equal some default thing. Gotcha. Okay, I'm getting it now. Type references. Oh man, I'm so close to done with this section. Sweet. Type references. GraphQL describes the types of data expected by arguments in variables. Input types may be lists of another input type or a non-null variant of any other input type. GraphQL describes the types of data expected by arguments in variables. Sure, these are just types. Input types may be a list of another input type. Okay. Type, name type. List type, non-null type. Sure. Name be the string value of name. Type be the... I don't know. I think this is a complicated way to talk about how you define types. I don't think I need to look at that. Directives, my arch nemesis, my arch enemy. What are they? I've never used these before, never seen them before. So we have a directive. At name arguments. Directives provide a way to describe alternate runtime execution and type validation behavior in a GraphQL document. Okay, why would you need to do that? In some cases, you need to provide options to alter GraphQL's execution behavior in ways field arguments will not suffice. This sounds dangerous, such as conditionally including or skipping a field. Directives provide this by describing additional information to the executor. Directives have a name along with a list of arguments which may accept values of any input type. Any input type. Okay. Directives can be used to describe additional information for types, fields, fragments, and operations. Okay. As future versions of GraphQL adopt new configure execution capabilities, they may be exposed by directives. GraphQL services and tools may also provide additional custom directive. Okay, so this is just like custom stuff. Add external. So let's look at this example here. Directives may be provided in a specific syntactic order, measurements, and interpretation. These two type meaning and exclusion field. Yeah. Huh. Okay. Well, it doesn't really give you much. So I get the sense directives are special tags, we'll say, to tell the server to do something interesting. You specify them using at seems dangerous. If you're using them, you better know you're doing. That's my guess. Oh, heck yeah. On to the type system. Oh, I love it. The GraphQL type system describes the capabilities of a GraphQL service and is used to determine if a requested operation is valid, to guarantee the type of response results, and describes the input types of variables to determine if values provided at request time are valid. Okay, so we're on to the type system. Fields, language. Yeah, okay, so we want how many? 2. Interesting. That's not right. Right, if I go over here, document, yeah, that ain't right. That needs 3, okay. Describes capabilities of a GraphQL service, determines if a request operation is valid, describes the input types of, describes input types. Sweet. Type system document is a list of type system definitions. And a type system definition is a schema definition or a type definition or a directive definition. Sure. We know what a directive. Directives are special tags that tell the server. Interesting. So you can define your own directives. Ah, that's cool. Okay, so you can either define, really, I mean, you'll define directives perhaps, maybe, but mostly schemas and types. Interesting. GraphQL language includes an IDL. What is that? Interface Description Language. Generic term for a language that lets a program or object written in one language communicate with another program written in another language. IDLs are usually used to describe data types and interfaces in a language-independent way. For example, between those written in C++ and those written in Java. Huh. RPC stuff. Okay, sure. This is like a standard way to describe data? Huh. Includes an IDL. Tools may use this definition language to provide utilities such as client code generation or service bootstrapping. Client code generation, service bootstrapping. Huh. GraphQL tools or services which only seek to execute GraphQL requests and not construct a new GraphQL schema may choose to not allow type system definition. Tools which only seek to produce schema and not execute requests may choose to only allow type system document and not allow executable definition or type system extension, but should provide a descriptive error if present. Okay, so you can like have tools that only take certain types of GraphQL type system definitions. Sure, that makes sense. Type system definition language is used throughout the remainder of the specification document while illustrating example type systems. Okay. So an extension. Extension. Type system extensions are used to represent a GraphQL type system which has been extended from some original type system. For example, this might be used by a local service to represent data a GraphQL client only accesses locally, or by a GraphQL service, which itself is an extension of another GraphQL service. Sure, so we're like working off of some base classes or something. Tools which only seek to produce and extend schema and not execute requests may choose to only allow type system extension document and not allow executable definition, but should provide a description of error message if present. Sure. Okay. So does that, I don't think that's worth writing about. Types extend other types. Sure, that makes sense. Description is a string. Documentation is a first-class feature of GraphQL type systems to ensure the documentation of GraphQL service remains consistent with capabilities. Description of GraphQL definitions read along with their definitions and made available via introspections. So are we like into... No, we're not even into types. To allow GraphQL service designer. GraphQL service. Markdown syntax. Oh, that's cool. That's cool. Okay, yeah, I've seen this. No, that's neat. Schema describe, provide a description unless they're considered self-descriptive. Well described, yeah. Okay, cool. I'll say description. Descriptions are documentation. Represent documentation is a first-class concept in GraphQL. Schema. Okay, getting at interesting stuff here. GraphQL services' collective type system capabilities are referred to as that service's schema. Okay, so a schema is defined in terms of the types and directives it supports, as well as the root operation types for each kind of operation, query, mutation, and subscription, as well as the root operation types for each kind of operation. Okay, this determines the place in the type system where those operations begin. A GraphQL schema must itself be internally valid. This section describes certain rules. Okay, types of the GraphQL unique names. Describes the capabilities of a GraphQL service. Defined in terms of types, supports as well as types. Root operation types for each kind of operation. Yeah. Query, mutation, description. All types in the schema must have unique names. Schema defines the internal root operation type for each kind of operation it supports. Query, mutation, script. This determines the place, the type system where those operations begin. The query root operation type must be provided and must be an object type. Oh boy. Excuse me. Mutation root operation is optional. Not provided. The service does not support mutations. If it is provided, it must be an object type. Similarly, subscription, also optional. Query mutation, subscription, different types, if provided. The fields on the query root operation type indicate what fields are available at the top level of a Graphql query operation. Sure. Root operation types. We have query, mutation, subscription, optional. All defined as object types. Top level of a GraphQL operation. Interesting. Sure, so you have like a backing type, basically. Similarly, the following mutation is only valid if the mutation root operation type has a field name set name. Okay, so like your document that you construct must match the type that you have. So we see that types are sort of a first class thing in this as well. When using the type system definition language, a document must include at most one schema definition. Using the type system definition language. Schema document must include a schema. It's defined with both query and mutation root operation types. Okay, so this is just like another. Is that a document or type? I don't know what you define this as. I wouldn't say it's a selection set. Is that true? I'm not sure. Default root operation type names. Well, any type can be the root operation type for GraphQL operation. Type system definition language can omit the schema definition when the query mutation subscription root types are named query mutations. Likewise, when representing GraphQL schema using type schema definition, the default root. Sure. So if you're doing nothing fancy, then you can just call this query and mutation, and the schema will be generated from there. Sure, that makes sense. Schema extension. Schema extensions are used to represent a schema which has been extended from an original schema. For example, this might be used by GraphQL service which adds additional operation types or additional directives to an existing schema. Additional operation types. Interesting. Wonder why you do that. Schema extensions without additional operation type definitions must not be followed by a curly brace, such as a query shorthand, to avoid parsing ambiguity. The same limitation applies to the type definitions and extensions below. Schema potentially invalid, correct, undefined. Yeah. Yeah. Okay, so you can extend a schema. Cool. Types 3, 4. Yep. The fundamental unit of any GraphQL schema is the type. There are 6 kinds of named type definitions in GraphQL and 2 wrapping types. So we have scalar, scalar, object, interface, union, enum, input object. Interesting. Do we ever get to a definition of what a scalar is? Where does that show up? Oh, down here. Sure. Let's fill those in. Scalar types represents primitive leaf values in a GraphQL type system. GraphQL responses take the form of hierarchical trees. The leaves of this tree are typically GraphQL scalar types, but may also be enum types or null values. GraphQL provides a number of built-in scalars which are fully defined in the scenarios below. However, type systems may also add additional custom scalars to introduce additional semantic meaning. Interesting. Represent leaf nodes in the GraphQL hierarchy. Usually are things like int, float, string, boolean, ID. You can define your own objects. Operations are hierarchical and composed, describing a tree of information, while scalar types describe the leaf values of these hierarchical objects. Hierarchical operations object describe the intermediate levels. Describe, represent, intermediate nodes? I don't know. GraphQL objects represent a list of named, as a list of named fields associate and their values. That seems like a reasonable way to put that. Interface. GraphQL interfaces represent a list of named fields and their arguments. GraphQL objects and interfaces can then implement these interfaces, which requires that the implementing type will define all fields defined by those interfaces. Fields on a GraphQL interface have the same rules as fields in a GraphQL object. Their type can be scalar, blah, 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 or any wrapping. For example, interface, named entity. Okay, so it's just like a way to... Gotcha. Just like an interface in any other type system allows you to give a name bundle of types fields. A union. GraphQL unions represent an object that could be one of a list of GraphQL types, but provides no guaranteed fields between those types. Sure. It's sort of like an OR. They also differ from interfaces in that object types declare what interfaces they implement but are not aware of what unions contain them. Which is to say, if an object is part of a union, it does not know that. That makes sense? With interfaces and objects, only those fields defined on that type can be queried directly. Interfaces and objects only those fields defined on the type can be queried directly. Only the fields defined on the type. Yeah. To query other fields on an interface, typed fragments must be used. This is the same as for unions, but unions do not define any fields. So no fields may be queried on this type without using without the use of type refining fragments or inline fragments. Yeah, so a search result we're saying might be a photo, or maybe a photo, maybe a person. Search query first result is... Yeah, that makes sense. Give a name to a list of types joined by or. I think that's the right way to put it. Enums. GraphQL enum types, just like scalar types, also represent leaf values in GraphQL type system. However, enum types describe the set of possible values. Represent leaf nodes in the GraphQL hierarchy. Enum types describe set of possible values. Sure. And an input object. Fields may accept arguments to configure their behavior. These inputs are often scalars or enums, but they sometimes need to represent more complex. Oh, interesting. These are like, I didn't know this was like an actual special type. A GraphQL input object defines a set of input fields. The input fields are either scalars, enums, or other input objects. This allows arguments to accept arbitrarily complex structs. Sure. Types that define inputs sort of look like objects can only contain scalars, enums, or input objects. Yeah. Circular references. Circular reference occurs in yeah. Then we have some wrappers, I guess. Wrapping types. Seem to be both nullable and singular, e.g. a scalar string returns either null or singular string. A GraphQL schema may describe that a field represents a list of another type. The list type is provided for this reason and wraps another type. Okay, sure. Wrapping types. We have like a list. Represents many of a particular type. A non-null type wraps another type. Yep, non-null denotes that the never be null. These two types are referred to as wrapping types. Non-wrapping types are referred to as name types. A wrapping type has an underlying name type found by continually unwrapping the type until a name type is found. Sure. Then we have input and output types. Types are used throughout GraphQL to describe both the values accepted as input to arguments and variables, as well as the values output by fields. What does this say? Types are used throughout GraphQL to describe both the values accepted as inputs and outputs. Sure. These two uses categorize types as input types and output types. Some kinds of types, like scalar and enum types, can be used for both inputs and outputs. Other kinds of types can be only used for one or the other. Input types can only be used as input types, or input object types can only be used as input types. Object, interface, union types can only be used as output types. Interesting. I didn't know. I suppose that makes sense. Lists and non-null types can be used as input types or output types depending on the unwrapped type. Blah, 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 blah. Yeah, inputs and outputs. Sure, got it. Just want to say input and output. Scalar enum only be used as inputs. Input object. Object interface union only be used as outputs. Lists non-null can be used as both. Type extensions. Type extensions are used to represent GraphQL type which has been extended from some original type. For example, this might be used by a local service to represent additional fields a GraphQL client only accesses locally. I don't get that. I don't understand why that's useful. Or not. I can see how that'd be useful, but I don't really get... Sure, whatever. I'm just going to skip this. That doesn't feel relevant. Scalar types represent some primitive leaf. Okay, so we've already looked at this. We have our list of scalars here. Sure, don't mix types. Only put good things in those types. Data types, all reference built-in scalars must be included. Yep, custom scalars. Yeah, custom scalars, that's cool. Custom scalar types in addition to built-in scalars. For example, GraphQL service could define a scalar called UUID, which, while serialized as a string, conforms to RFC 4122. When querying field type UUID, you can then rely on the ability to parse the result with an RFC 4122 compliant parser. Another example of potentially useful custom scalar is URL, which serializes as a string but is guaranteed by the server to be a valid URL. Yeah, interesting. When defining a custom scalar, GraphQL services should provide scalar specification URL by the specified by directive or specified by URL. The URL must link to a human readable specification of the data format, serialization, coercion rules, and scalar. Sure. Alright, can define custom scalars like URL or UUID or anything else. Sure, that's cool. Result coercion. GraphQL service, when preparing a field of a given scalar type, must uphold the contract the scalar type describes, either by coercing the value or producing a field error if the value cannot be coerced. GraphQL service may decide to allow coercing different internal types to the expected return type. For example, when coercing a field type int, a Boolean true value may produce 1, or a string value may be 123, may be parsed as base 10, 1, 2, 3. However, internal type coercion cannot be reasonably formed without losing information. Sure, so we can convert between the two. Yep, coercion. You can do coercion of the input types as well. Sounds reasonable. We have our int. It's 32-bit signed numeric non-fractional value. Yeah. Coercion, blah, blah, blah. Float, sure. String, Boolean, yep. ID. What is an ID? ID scalar type represents a unique identifier often used to refetch an object or as the key for a cache. The ID type is serialized in the same way as string. However, it is not intended to be human readable. While it is often numeric, it should always serialize as a string. Cool. I'm into it. Scalar extension. Scalar type extension represents scalar extended from some original scalar type, which adds directives to existing scalar. Whatever. Don't know about it. Don't know about that. Objects. Graphql operations are hierarchical and composed, describing a tree of information, while scalar types define the leaf nodes. Types describe the intermediate levels. Sure. Graphql objects represent less than a field. Each one deals with a type. As ordered maps. Selected field names are the keys, the result of value. Yep. All fields defined within an object type must have. Yep. Sure. Query of an object value must. A query of an object value must select at least one field. The selection of fields will yield an ordered map containing exactly a subset of the object query. Sure. So you got to query something. For example, selecting all fields would yield this object while selecting the subject a field of any object. Scalar, enum, or other object type, interface, or union. Additionally, maybe any wrapping type whose underlying base type is one of those 5. Yep. Sure, that's interesting. Okay. Objects. Name. You must, if you are querying an object, you must select at least one field within object. When querying an object, the resulting mapping of fields are conceptually ordered in the same order in which they were encountered during execution, excluding fragments for which the type does not apply, and fields or fragments that are skipped via add skip or include. Asserting correctly produced when using the collect fields algorithm. Response serialization formats capable of representing ordered maps should maintain this ordering. Blah, 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 ordering, blah, 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 producing response represented in the same order, produce human readability. Sure, it'd be cool to make sure they're ordered. Love it. Foo, frag. Ordering. Type validation. Interesting. Okay, do we care about this? Object types must define one of the more fields. For each type, field and object type. That's cool. Okay. I don't think I really need to look at this too hard, but that's a good, really good. Nah, that's not what I wanted. This. Yeah. Object fields are conceptually functions which yield values. Occasionally, object fields can accept arguments to further specify the return value. Object field arguments are defined as a list of all possible argument names and their expected input types. All possible argument names and their expected... Yeah, sure. All arguments defined within a field must not have a name that begins with dash dash. For example, person, picture. Object fields may take arguments to specify their output. That's cool. You can mark things as deprecated. You can mark fields as deprecated. Extensions, sure, we know what you can extend objects. Great, love it. Interfaces, GraphQL interfaces. Example, named entity. We looked at this already. Selecting fields on an interface type. Only those fields declared in the interface may be queried. Entity returns. Sure, we don't know that an entity has an age. Makes sense. Result coercion, input coercion, more validation, interface extensions, blah, blah, blah. Unions is just like sort of an OR over types. Anything interesting going on there? Not really. Union extensions, yeah, you can extend those. Cool. Coercion, enums, extensions, okay. Input objects. Fields may accept arguments, configure the behavior. Yeah, you can define objects as those things. Don't do circular references. Sure, makes sense. Well, what do we have going on here? A list. No. Hey, what's a nullable versus optional? By default, all types in GraphQL are nullable. That's interesting. The null value is a valid response for all of the above types. To declare a type that disallows null, the GraphQL non-null type can be used. This type wraps an underlying type, and this acts identically to that wrap type, with the exception that null is not a valid response. Trailing exclamation mark is used to denote nullable versus optional. Fields are always optional within the context of a selection set. A field may be omitted and the selection is still valid. However, fields that return non-null types will never return the value null if queried. Oh, sure. So like fields are always allowed to not exist in a query, but if you do query them, the nullability will become a factor in what value they return. So by default, if you query a field, it can be null, and if you query a field and its type is a non-null, the non-null wrapper is applied to the type, then it can only have a non-null value. That makes sense. Result coercion. Input coercion, more coercion, combining list and non-null. The list and non-null wrapping types can compose, representing more complex types. The rules for result coercion and input coercion of list and non-null types apply in recursive fashion. For example, if the inner type of a list is non-null, then that list may not contain any null items. However, if the inner type of a non-null is a list, if the inner type of a non-null is a list, sure, the null is not accepted. However, an empty list is accepted. Right. That makes sense to me. Directives. Okay, more GraphQL. Schema describes directives which are used to annotate various parts of a GraphQL document as an indicator that they should be evaluated differently by validator, executor, or client such as a code generator. Okay. Directives. Annotations which tell validator, e.g. validator, executor, or client tool to evaluate something differently. Built-in directive. We have at skip and at include. And we have deprecated. Graphql implementation supports the type system definition language being specified by. When representing Graphql schema, the type system definition, any built-in directive may be omitted for brevity. Custom directives. GraphQL services and client tooling may provide additional custom directive beyond those defined in this document. Directives are a preferred way to extend GraphQL with custom or experimental behavior. All right, so they're totally custom stuff, probably pretty advanced. Can define custom directives. Seems like a very advanced use case. Cool. All right. Well, if I ever need that, I can read this. Skip built-in directive may be provided for fields, fragment, and conditional exclusion during execution as described by the if argument. Takes if boolean, skip the line if the arg is true. Yeah. Include built-in directive may be provided from fields unless for conditional inclusion during execution. The inverse of skip, it seems. Both are essentially if statements. Indicates deprecated sections. Yep, specified by built-in directive provides scalar specification URL. Provides a place to put a URL that defines a scalar specification. Okay, on to introspection. How many hashes should I have here? Types, probably 3. Interesting. How big is this section? Field type. Okay, cool. Introspection. GraphQL service supports introspection over its schema. This schema is queried using GraphQL itself, creating a powerful platform for tool building. So, like, I can ask about the schema and what it looks like. Cool. Let's see. Take an example request for a trivial app. In this case, there is a user type with 3 fields, ID, name, and birthday. For example, given a service with the following type definitions, we've got a user, a request. We can ask about, I guess, the type of a user, and we can get its name and then the fields. Okay, so like I would think this will return the name and then the ID, name, and birthday, and it will have the name of the field as well as like a string date. is that true? So we have user, and then we have our list of fields here. ID, string, yep, Okay. Introspection allows queries to find out about the schema of a GraphQL service. So, for example, I can ask, what's the type of this object and what fields does it have? Yeah, sounds pretty good. Okay. Reserve name types and fields required by the GraphQL introspection system that are used in the same context as user-defined types and fields are prepended with 2 underscores. This in order to avoid naming convolutions with user-defined object types, user-defined GraphQL types. Otherwise, any name within a GraphQL type system must not start with 2 underscores. Sure. Is that just saying reserved names start with underscores? Types and fields that are used in the same context as user-defined types and fields are prefixed. Sure. Yeah, so anything related to GraphQL stuff is underscore underscore. That makes sense. Names provided by GraphQL start with what do they call them? Yeah. Other names that start with. Yeah. Cool. Okay, type name introspection. GraphQL supports type name introspection within any selection set in an operation, with the single exception of selections at the root of a subscription operation. Did I define vocab? Selection set's pretty good. Let's define that. How do we define that? So we're on 4.1. I bet we have a definition. Receive exactly. So what are you going to do? The set of information that an operation opts to receive for E except after C. Yep. Only this set of information is returned from a query from an operation, or is returned as the result operation. Yeah. Okay, back to introspection. GraphQL supports type name introspection within any selection set in an operation. Yep. With the single exception of selections at the root of a subscription operation. Okay, I don't really know much about subscriptions yet, but maybe that's a thing we'll get to. Type name introspection is accomplished via the meta field underscore underscore type name, which is a thing that takes a string on any object, interface, or union. Returns the name of the concrete object type at that point during execution. Okay, so like I can ask for something, and I can also ask for its type name. Cool. This is most often used when querying against interface or union types to identify which actual object type of the possible types has been returned. Yeah, sure, okay. As a meta field, type name is implicit and does not appear in the fields list in any defined type. Type name may not be included as a root field in a subscription operation. It's a root field in a subscription operation. Interesting. Wonder why that's special. Type name. You can query any field's type name by asking for the type name field. It exists on any objects. Type name returns name. Is it a field or an object? I mean, it's kind of the same. Any fields, any objects. It exists on any object except root field of a subscription operation. The schema introspection system is accessible from the meta fields schema and type, which are accessible from the type of the root of a query operation. What does that exactly mean? The schema introspection system is accessible from the meta fields schema and type, which are accessible from the type of the root of a query operation. So is that to say that I can ask for type name? No. I don't really understand what that second part means. First class documentation. All types in the introspection system provide a description field type string to allow type designers to publish documentation in addition to capabilities. Graphql service may return the description field using markdown syntax as specified by common mark. Therefore, it is recommended that any tool that displays description use a common mark compliant markdown renderer. That's cool. That's pretty neat. I'll write that down. I really like the fact that you can document types in GraphQL natively. All types have the ability to return a description field. That is a string. The string is assumed to be string can contain markdown following the common mark syntax specification. Yeah, that's neat. Deprecation. To support the management of backwards compatibility, GraphQL fields and enum values can indicate whether or not they are deprecated and a description of why it is deprecated. Tools built using GraphQL introspection should respect deprecation by discouraging deprecation use through information hiding or developer-facing warnings. Sure. Deprecation. Fields can be deprecated with is deprecated fields and deprecation reason. Yeah, that's cool. Schema introspection schema. All right, that's a little recursive. The schema introspection system itself is represented as a GraphQL schema. Okay. Below are the full set of type system definitions providing schema introspection, which are fully defined in the sections below. So we have a type of schema, has some types, query type, mutation type, description type. directive. And we have a type, which is a type kind. Which is like some of these. We got all these things. We got our fields. Sure, so you can like recursively go through a schema and find all the stuff about it. Yeah. Okay, cool. That's neat. Schema type is returned from the schema meta field. I don't particularly care about these things. Or do I? I don't know. Let's see. The schema type is returned from the schema meta field and provides all information about the schema of a GraphQL service. Description, query type, mutation type, subscription type, types, all name types. Oh, that's neat. Directives. Type is at the core of the type introspection system. It represents all types in the system, both name types and type modifiers. Yep. Type modifiers are used to modify the type presented in the field of type. This modified type may recursively be a modified type representing lists, non-nullables, and combinations thereof, ultimately modifying a named type. There are several kinds of type. In each kind, different fields are actually valid. All possible kinds are listed in the type kind enum. Each subsection below defines the expected fields of type, given each possible value of the type kind enum. So we have like a definite list of types, which is cool. So let's write that down. Types and type kind. Scalar, object, interface, union, enum, input object. I wonder what input object means. Why is that different than just an object list? No. Yeah, that's just like a int, string, boolean, custom scalars. Yep. Object. Concrete instantiation of sets of fields. Yeah, that's a good way to put it. Sets of fields. Yep. A union or an abstract type with no common fields, where no common fields are declared. The possible types of union are explicitly listed out in possible types. A thing representing one of several possible types. Interface, an abstract type with the common fields declared. Any type that implements an interface declares common set of fields. Implementing type must define all those fields. Yeah. Enums are special scalars that can only have defined set of values. Finds a set of values. Yep. Input object. Input objects are composite types defined as a list of named input values. Okay. They are only used as inputs to arguments and variables and cannot be a field return type. I don't understand why that needs to be special. Maybe there's... Interesting. I don't really know. Defines a set of named input values. Yeah, why are these different than... Don't need a period there. Yeah, why are these different than objects? Object representing concrete instantiation of sets of fields. Doesn't really say. A list represents a sequence of values. sequence of values and non-null type modifier indicating type cannot be null, obviously. The __ field type. The field type represents each field in an object or interface type. Sure, these are like meta types. We have the field type, the input value type, enum value, and directive, which is to say, represents each field in an object. This is just like what is returned when we ask what type a thing is. Yeah, okay. Input value represents field directed on the input fields of an input object. Input value type represents field and directive arguments. Yep. Enum value. Yep. Yeah, okay. Cool. All right, on to validation. How big is this one? Looks pretty big. Yep. That's pretty big right there. Whoa, that's really big. Okay. See how far we get with that. GraphQL does not just verify if a request is syntactically correct, but also ensures that it is unambiguous and mistake-free in the context of a given GraphQL schema. An invalid request is still technically executable and will always produce a stable result as defined by the algorithms in the execution section, which is next. However, that result may be ambiguous, surprising, or unexpected relative to a request containing validation errors, so execution should only occur for valid requests. Sure. Typical validation is performed in the context of a request immediately before execution. However, a GraphQL service may execute a request without explicitly validating it if that exact same request is known to have been validated before. Okay, so we can skip validation if we have cached. For example, the request may be validated during development, provided it does not later change, or a service may validate a request once and memorialize the result to avoid validating the same request again in the future. Any client-side or development time tool should report validation errors and not allow the formulation or execution of requests known to be invalid at that given point in time. Sure. Let's see, type system evolution. As GraphQL type system schema evolves over time by adding new types and new fields, it is possible that a request which was previously valid could later become invalid. Any change that can cause a previously valid request to become invalid is considered a breaking change. Yeah. GraphQL services and schema maintainers are encouraged to avoid breaking changes. However, in order to be more resilient to these breaking changes, sophisticated GraphQL systems may still allow for the execution of requests, which at some point were known to be free of any validation errors and have not changed since. Sure. For this section of the schema, we will assume the following type system in order to demonstrate examples. So we have a query. It's going to ask for a dog. The dog implements pet, which has a lot of stuff. And a pet is implemented here, has a name. We have a dog command. If we know a command is house trained, sure. Okay, cool. Alien implements humans, implements setting. Dog or human, yep, okay, looking at documents. Validation. So maybe write down what I just learned there. GraphQL service should validate a GraphQL request before executing it. It should not execute the request if it is invalid. Cool. Done. Simple. Formal specification for each definition in the document. Definition must be executable definition. It must not be type-safe definition or extension. Type system definition or extension. Sure. So we have to have something that is executable. Yep. GraphQL execution will only consider the executable definitions, operation, and fragment. Yeah, type system definitions and extensions are not executable and not considered during execution. Sure. To avoid ambiguity, a document containing type system definition or extension is invalid for execution. Yes. GraphQL documents are not intended to be directly executed. GraphQL documents not intended to be directly executed may include type system definition or extension. For example, the following document is invalid for execution since the original executing schema may or may not know about the provided type extension. Color. Sure. If we're defining get dog name and also extend type dog, and we add color to dog, but we do that in our client, the server doesn't know about that and doesn't know how to do it. That makes sense. How to return that. Yep. So what? Executable definitions. I will just say a GraphQL service does not / cannot take into account types that are defined client side. Named operation definitions, operation name uniqueness. For each operation definition, operation in the document, let operation name be the name of the operation. If operation name exists, let all operation definitions in the document named operation name. Operations must be a set of one. I kind of get that. Each named operation definition must be unique within a document when referred to by its name. Man, I'm making so many speaking mistakes, not like typos. I don't know what you call them. There are no typos in this. This is incredible. So well proofread. For example, the following document is valid. Yeah, so we have a query, get dog name, get owner name, and we have two that have the same name, and we can't do that because we can't have things that are the same name. That makes sense. I don't think that's worth talking about. Anonymous operation definitions. Lone anonymous operation. I'm not going to read the formal stuff because that's too formal. GraphQL allows a shorthand for defining query operations when only that operation exists in the document. Sure, this is just a query. We have one document. All it is a query. We don't need to name the query, but we can't do that if we have multiple queries in the document. Makes sense. Subscription operation. Subscription operations must have exactly one root field. Yeah, let me write. Okay, let me. I'm just going to do this, I guess, and then. Maybe we'll do like documents. This is operations. Must have a unique name. In the context of the document. Did I define document? Document. Yes. Yep. Boop, boop. Can be defined without a name as long as there's only one operation in the document. Yeah. Okay, on to subscription operation. Subscription operations must have exactly one root field. Subscription operations must must have one root field. Yep. New message fields. Subscription. Yep, that's fine. That's the same thing. We're selecting one thing, but as soon as we try to select two things for a subscription, can't do that. Cool. The root field of a subscription operation must not be an introspected field. The following example. Sure. Well, each subscription must have exactly one root field. A document may contain any number of operations, each of which may contain different root fields. When executed, a document containing multiple subscription operations must provide the operation name as described in get operation. Sure. That makes sense. Is there anything else? Subscription operations must not define their root field as type name. Yeah. Fields. Field selections must exist on object, interface, or union types. When, what does that mean exactly? Field selections. The target field of a field selection must be defined on the scoped type of the selection set. There are no limitations on alias names. For example, the following fragment would not pass validation. Fragment. Field not defined on dog. Sure. Alias lying field target not defined. Bark volume. Dog. Yeah. Right, because we don't have... How do we define an alias? This is what we call it. This is the source, yeah. Right, so it doesn't have call volume. We can't call it bark volume. That won't work. Yep. Field selection must exist on object, interface, and union types. I suppose that is to say object, interface, and union types must select one or more fields. Yeah. Fields must exist. Types. They're being used within. Used in. Yep. Because unions do not define fields, fields may not be directly selected from a union-typed selection set, with the exception of the meta field type name. Fields from a union-typed selection set must only be queried indirectly via fragment. Unions cannot how do I say this in a more authoritative way? Fields cannot be selected on a union. They must be selected directly via a fragment on that union. Yeah. Field selection merging. Okay, this is, whoa, that's really long. If multiple field selections with the same response names are encountered during execution, okay, multiple field selections with the same response names are encountered during execution. Sure. The field and arguments to execute and the resulting value should be unambiguous. Okay, therefore, any two field selections which might both be encountered for the same object are only valid if they are equivalent. During execution, the simultaneous execution of fields of the same response name is accomplished by merge selection sets and collect fields. For example, handwritten GraphQL. For simple handwritten GraphQL, this rule is obviously a clear developer error. However, nested fragments can make this difficult to detect manually. Yes. The following selection sets correctly merge. Sure. Selecting the same field more than once is valid and will be merged by merge selection sets collect fields. Sure, you can't rename, nickname, and query name. Those are not the same. They're not coming from the same place. Yep. Identical arguments are also merged if they have identical arguments. What? Both values and variables can be correctly merged. For example, the following correctly merge. Merge identical fields with the dialysis and dog. Does no command. Dog. Sure. Selecting the same field more than once is valid and will be merged by with the same arguments. Yep. Following fields would not merge together. However, both cannot be encountered against the same object, so they are safe. Safe differing fields. We have a volume. Yep. Right, because we're only going to get one of these. It does no command. Yep, that's fine. We're only going to get one of those. Yep. Leaf field selections. Field selections on scalars or enums are never allowed because they are leaf nodes of any GraphQL operation. Yeah. You aren't able to select fields on scalars or enums because they don't have any fields. Leaf nodes within a GraphQL operation. Yeah, you aren't able to select fields on scalars or enums. Yep. Yeah, that makes sense. We don't really need to go too far into that. Okay, on to arguments. Arguments are provided to both fields and directives. The following validation rules apply in both cases. Every argument provided to a field or directive must be defined in the set of possible arguments of that field or directive. For example, the following are valid. We have a fragment, does no command, dog command. At other homes, true. Include if true. The following is invalid since command is not. That's pretty straightforward. You can only use arguments that are defined. Yep, that makes sense. And fields and directives treat arguments as a mapping of argument name to value. More than one argument with the same name, an argument set is ambiguous. Must only reference defined arguments. Must not have multiple arguments with the same name. Straight up, that makes sense. Required. Arguments can be required, and argument is required if not all there's argument optional. Yeah, that is pretty self-explanatory. Fragments. fragment name uniqueness. Fragment definitions are referenced in fragment spreads by name. To avoid ambiguity, each fragment's name must be unique within a document. Sure. Each fragment's name must be unique within document. That makes sense. I bet you can alias them. Inline fragments are not considered fragment definitions and are unaffected by this validation rule. Interesting. Fragment spread type existence. Fragments must be specified on types that exist in the schema. This applies for both named and inline fragments. If they are not defined in a schema, the fragment is invalid. Duh. Don't think I need to write that out. Fragments on composite types. Fragments can only be declared on unions, interfaces, and objects. Yeah, that makes sense. They're invalid on scalars, sure. They can only be applied on non-leaf fields. Yep, this rule applies to, yeah. Fragments can only be declared on unions, interfaces, objects. They cannot be. Is cannot one word or two words? Let's just say it's two words because I don't know, that seems right. They cannot be declared on leaf, nodes, scalars, or enums. Yeah. That makes sense. Fragments must be used for each fragment. Defined fragments must be used within a document. For example, the following. Huh, that's interesting. If a fragment is defined within a document, it must be used. Field selection is also determined by spreading fragments into one another. Yep, the selection set of the target fragment is combined into the selection set at the level in which the target fragment is referenced. Name fragment spreads must refer to fragments defined within the document. It is validation error if a target spread is if the target of a spread is not defined. Sure, that makes sense. Fragment spreads must not form cycles. Yeah. Graph fragment is running on its otherwise an operation could eventually start Yep. That makes sense. I guess. Fragments spreads must not form cycles. Fragment spread is possible. Fragments are declared on a type and will only apply when the runtime object matches the type condition. They're also spread within the context of a parent type. A fragment spread is only valid if its type condition could ever apply within the parent type. What? Oh, sure. So it's like fragments are declared on a particular type and will only ever be valid for use on that type. Yeah, that is kind of obvious. Object spreads in object scope. This is section 5.5.2.3.1. In the scope of an object type, the only valid object type fragment spread is one that applies to the same type that is in scope. What? In the scope of an object type? The only valid object type fragment spread, is one that applies to the same type that is in the scope. Yeah, that kind of seems like the same thing as the previous one. You can only spread a fragment of a type inside of an object of the same type. In scope of an object type, unions or interface spreads can be used if the object type implements the interface or is a member of the union. Also makes sense. I think that's kind of the same thing. Object spreads, unit interface, context, but only if the type is possible. Yeah, okay, same thing. Unit interface, as long as there exists one object type that exists, the intersection of possible types the spread is union with interface, on pet, dog, or human fragment. Yep, that makes sense. Okay, on to values. All that was pretty obvious. For each input type, oh, no, I can read that. Never mind. Literal values must be compatible with the type expected in the position they are found as per the coercion rules defined in the type system chapter. The type expected in a position includes the type defined by the argument a value is provided for, the type definition by an input object field a value is provided for, and the type of a variable definition a default value is provided for, which is to say, if I ask for a type, then it must show up in the right place. I believe that's what that is saying. Get boolean arg. Boolean arg field. Boolean arg true. Coerced into float. Note the input coercion rules reflect. Yep. Yeah, complex input. Non-coercible types are invalid. Literal values must be compatible with the type expected in the position they're found as per the coercion rules. Sure, that makes sense. You can't use the wrong type. If you're expecting an int and you give a string, you can't do that. That is obvious. Input object field names. For each input object field, okay, whatever. Every input field provided in an input object value must be defined in the set of possible fields that field of that input object's expected type. For example, the following example, find dog. Complex takes a name, Fido. We can't have complex, takes a fair cookie. Yeah, gotta have the right. You can't select things that aren't defined. That makes sense. Input objects must not contain more than one field of the same name. Otherwise, an ambiguity would exist, which includes an ignored portion of syntax. Can't have two fields. Yep, that is off, yes, as well. Input object required fields. Input object fields must be required, may be required, much like a field required fields and required non-total type to default value. Okay. Values, literal values must be of the correct type. Values, value names are unique. That's pretty much it. Directives. GraphQL services define what directives they support. For each usage of a directive, the directive must be available on that service. That makes sense. GraphQL services define what directives they support and whether they support them. For each usage of a directive, the directive must be used in a location the service has declared support for. Yep. Directives can only be used where they are supported. I don't know. I mean, that's kind of so obvious. Directives are unique per location. For every directives are used to describe some metadata or behavioral change to the definition they apply to. When more than one directive of the same name is used, the expected metadata becomes ambiguous. Therefore, only one of each directive is allowed per location. Yeah, we can't have two skips. Sure, that makes sense. That's so obvious. Variables. If any operation finds more than one variable with the same name, it is ambiguous and invalid. Yes. Must have unique names. Cool. Variables are input types. Variables can only be input types. Objects, unions, interfaces cannot be used in input. Yeah, why not? Variables must be of type input. All variable use is defined. Variables are scoped on a per operation basis. That means that any variable used within the context of an operation must be defined. Yep, that makes sense. That's very obvious. All variables used. All variables defined by an operation must be used in an operation or fragment transitively included by that operation. Unused variables. No. Variables. Only those variables that are defined can be used. Those variables are defined. Use must be defined. Can be no extra variable definitions. Yeah, interesting. All variable usages are allowed. Variable usages must be compatible with arguments they are passed to. Validation failures occur when variables are used in the context of types that are complete mismatches, or if a nullable type in a variable is passed to a non-nullable argument type. Int arg, boolean arg. Yeah, the types must match up. Must match up. That makes sense. Don't need to go too far into that. Allowing optional variables when default values exist. I'm going to read this. Int arg typed cannot be used in boolean arg. Yep, that makes sense. Nullability must also be in general. Non-null. Null variable cannot be passed to a non-null. For list types, the same rules around nullability apply to both outer types and inner types. A nullable list cannot be passed to a non-null list. And a list of nullable values cannot be passed to a list of non-null values. Yep, sure. However, a nullable list cannot be passed to a non-null list. Sure. Allowing optional variables when default values exist. A notable exception to typical variable type compatibility is allowing a variable definition with a nullable type to be provided to a non-null location as long as either that variable or that location provides a default value. Notable exception to variable definition with a nullable type to be provided to a non-null location as long as either that variable... Sure, so if we have a default value in the null variable, yeah, it will have... This is optional. This is... provides a default value in the schema. Yeah. Yeah, cool. Execution. Let's see. I'm doing pretty good here. I think we can... I'm doing good. Execution. Yeah. GraphQL generates a response from a request via execution. Great. A request for execution consists of a few pieces of information. The schema to use, typically solely provided by the GraphQL service. Request for execution consists of a few pieces of information. Okay, that's pretty interesting. Generates a response by executing stuff. A request, a GraphQL request contains the schema to use provided by the GraphQL service. A document that contains an operation. Yep. The name of the operation in the document to execute. Optional. The name of the operation in the document to execute. Values for any variables defined in the operation. Optional values for variables in the operation. An initial value corresponding to the root type being executed. Conceptually, an initial value represents the universe of data available by a GraphQL service. It is common for a GraphQL service to always use the same initial value for every request. What? What does that mean? Corresponding to the root type being executed. I don't really understand what that means. An initial value corresponding to the root being executed, which is to say, like, if I'm asking for some fields on the query type has an initial value? I don't understand that. Executing requests. How long is this? So I go here. Yeah, all right. Um, 6.1, executing a request. To execute a request, the executor must have a parsed document and a selected operation name to run if the document defines multiple operations. Otherwise, the document is expected to only contain a single operation. Sure. The result of the request is determined by the result of executing this operation according to the executing operation section below. Sure. That all is pretty obvious. So we execute a request given a schema document, operation name, variable values, and initial value. So this is pretty formal. How much do I care about this? Let operation be the result of get operation. Ooh, you can highlight these things? Oh, that's fun. What happens if I click on that? Oh, that's fun. Where does that take me? Oh, down here. Oh, gosh, that's so neat. Let operation be the result of get operation. Yeah, so we're going to grab the operation from the document. Then we're going to coerce the variable values to be the result of, sure, that. If operation is query operation, we're going to execute the query. Otherwise, we're going to execute the mutation. Otherwise, we're going to execute the subscription. Okay, that's pretty interesting. So X steps to, what is this called? Executing requests. 1, we're going to get the operation. 2, get the variables used in the operation. 3, run the operation. Yeah, run the operation basically. Oh, where does this take us? Ooh, cool. Cool. Oh, so this is like that's all right, whatever. Validating requests. As explained in the validation section, only requests which pass all validation rules should be executed, right? If validation errors are known, they should be reported to the list of errors in the response, and the request must fail without execution, right? Typically, validation is performed in the context of a request immediately before execution, so that goes like validate the request. 4. However, a GraphQL service may execute a request without immediately validating it if the exact same request. Sure. Coercing variable values. If the operation has defined any variables, then the values for those variables need to be coerced using the input coercion rules of variables declared type. There's the typo. Finally, of the variables declared type. If a request error is encountered during input coercion of variable names, then the operation fails without execution. Validate the request. So this is like coerce input variables. Coerce variable values. Let coerce values be an empty order. Variable definitions. Each variable definition. Variable name. Variable type. Is input type. Those got to match. Default value. Has value. Value be provided. Has value is not true. Otherwise. Okay, yeah. Let's see. Executing operations. Executing requests. Executing operations. Okay. Type system, as described in the type system section of the spec, must provide a query root operation type. If mutations or subscriptions are supported, it must also provide a mutation or subscription root operation type, respectively. Yeah. Each operation to execute begins with a root. Query, mutation, or subscription. Root object, yeah. If the operation is a query, the result of the operation is the result of executing the operation's top-level selection set with the query root operation type. So it's sort of a recursive thing. An initial value may be provided when executing a query operation. Initial value may be provided when executing a query operation. I still don't understand what that means exactly. Let query type be the root of query type in schema. Assert query type as an object. Let selection set be the top level selection set in query. Let data be the result of running execute selection on the object. Let errors. Yeah, okay. Operation is a mutation. The result of the operation is a result of top level mutation. The selection will be executed serially. The selection set should be executed serially. That's interesting. Whereas up here, wasn't there something about parallelized? Allowing parallelization. Whereas this is serial. Query fields may be executed in parallel. Mutation fields must be executed serially. Interesting. It is expected that the top-level fields in a mutation operation prevent side effects on the underlying data system. Yeah. Did I say that already? Side. I didn't. Let's write that down. Mutation. Serial execution of the provided mutation ensures against race conditions during the side effects. Yeah. Subscription. If the operation is a subscription, the result is an event stream called the response stream, where each event in the event stream is the result of executing the operation for each new event on an underlying source stream. Operation is a result is an event stream called response stream, where each return an event stream, aka response stream. Each event, the result of executing the operation, each new event in an underlying source stream. Don't really know much about that. Executing a subscription operation creates a persistent function on the service that maps an underlying source stream to a returned response stream. Interesting. I don't really know what a source stream is. That sounds cool. In large-scale subscription services, the subscribe and execute subscription event algorithms may be run on separate services to maintain predictable scaling properties. Interesting. Subscription, new messages, new message, sender text. That's a good example. Interesting. Do I care about these things? Yeah, maybe. I don't know why it's here. Maybe we'll say event streams. An event stream represents a sequence of discrete events over time, which can be observed. As an example, a pub sub system may produce an event stream when subscribing to a topic, with an event occurring on that event stream for each published to that topic. Sure. Event streams may produce an infinite sequence of events, or may complete at any point. Event streams may complete in response to an error, or simply because no more events will occur. An observer may at any point decide to stop observing an event stream by canceling it. Yeah. Yep. Supporting subscription is a challenge for any GraphQL service. Query and mutation operations are stateless, allowing scaling by cloning of GraphQL service instances. Subscriptions by contrast are stateful and require maintaining GraphQL document variables in other contexts over the lifetime of the subscription. Yep. Consider the behavior of system. State is lost due to failure of a single machine or service durability and availability, blah, blah, blah. Stream, content of the stream, closing the stream. Source stream. A source stream represents the sequence of events, each of which will trigger a GraphQL execution corresponding to the event. Yep. Like field value resolution, the logic to create a source stream is application specific. So we can create a source event stream for a subscription schema, variable values, initial value. Interesting. Yep. Each event in the underlying source stream triggers an execution of the subscription. Yep, that's fine. Unsubscribe. Cancels the response stream when a client no longer wishes to receive payloads for a subscription. Yeah, okay, so like the pub sub publish is like a source stream. Subscribe is an event stream or response stream. Executing selection steps. To execute a selection set, the object value being evaluated and the object type need to be known. The object value being evaluated and the object type need to be known, as well as whether it must be executed serially or may be executed in parallel. First, the selection set is turned into a grouped field set. Then, each represented field in the grouped field set produces an entry into a response map. I think I get that. Let grouped field set be the result of collect fields. Don't want to look at that. It's kind of complicated. Initialize result map to an empty ordered map for each grouped field set as response key and fields. Let field name be the name of the first entry in fields. Notes alias is used. Field type. The response value being executed. Execute field. Field type be the return type. Field type. Where are we using that? Field type object. Fields, variable names. Group field as response for each group field set as response key. And fields. Set response value as the value for response key and result map. Sure. So basically, we get a sort of a object, a definition of things we would like to fetch. We have their names, we have their types, we know how to fetch them, we know what the resolver is, and basically we're going to go through that list of entries, execute the resolver, and set the value of that resolution onto the response using the same name and the same type. Yeah, makes sense. I think. I don't know. Actually, that's pretty good to know. That's good stuff. Executing selection. To execute a selection step set object value being evaluated and the object type need to be known, as well as whether it must be executed serially or may be executed in parallel. Yes. Object value being evaluated. Yeah. First, the selection set is turned into a grouped field set. What is a grouped field set? It's a result of collect fields. I do want to know what that is. Then, each represented field in the grouped field set produces an entry into a response map. I think I get that. What is this? Where is this? Field collection. Before execution, the selection set is converted into a grouped field set by calling collect fields. Each entry in the grouped field set is a list of fields that share a response key. The alias if defined. Each entry in the grouped field set is a list of fields that share a response key. Otherwise, the field name. Yeah. This ensures all fields with the same response key, including those reference fragments, are executed at the same time. Wait, is this just talking about how you can name things the same and it will sort of collapse those? A, subfield 1. A, subfield 2. As an example, collecting the fields of this selection set would collect 2 instances of the field A and 1 of field B. Why is that relevant? The depth first search order of the field groups produced by collect fields is maintained through execution, ensuring that fields appear in the executed response in a stable and predictable order. That's nice. So we're going to get, for a second, turn in a grouped field set. Then each represented field in the group field set produces an entry into a response map. Is the grouped field set, is that just the process of collapsing? I guess I really do need to read that collect fields. If visited fragments is not provided, initialize to be an empty set. Initialize group fields to empty ordered map. For each selection in selection set. So, for example, subfield 1 and subfield 2, or A and A, perhaps. Yeah, maybe that's a good way to put it. A and A. If selection provides the directive, skip, no. If selection provides the directive, include, don't care. If selection is a field, yeah. Let response be the key response key of selection, otherwise the field name. If selection is a field for each selection and selection set. So A. Response key is equal to A. Let group for response key be the list in group fields for response key. So far we have nothing like that. If no such list exists, create it as an empty list. Append selection to the group for response key. Group for response key. So we're going to like add A. A is going to be a key, and then there's a list, and then we're going to add this selection to a list. Okay, I can kind of see where this is going. This would be a good thing to diagram. Selection is a field. Yep. Response key. Yep. Okay. So, all right, let's see. If selection is a fragment for spread here, let fragment spread name be the name of the selection, which is example fragment. If fragment spread name is in visited fragments, continue with the next selection in selection set. Okay. So we're doing like a visitor sort of thing. So let's say we haven't looked at this fragment yet. We're going to add it to our visited fragments. Let fragment be the fragment in the current document whose name. So we're going to grab the fragment using the name. If no such fragment exists, continue the next selection in selection set. Let fragment type be the type condition on fragment, which is to say this fragment, here's the type on query. If does fragment type apply is false, continue. Okay, so we can only use named fragments that are for the correct type. Let fragment selection set be the top level selection set of fragment. So for us, that would be A and B. Yep. Let fragment group field set be the result of calling collect fields. So we're going to do the same. We're going to do it recursively. So we're going to create an object that has a key of A, which maps to a list containing this one element, and a key of B, which maps to a list containing that one element. Okay. For each fragment group in fragment group field set. Okay, let response P be the response key shared by all fields in fragment group. Fragment group field set for each fragment group shared by all fields in fragment group. What does that mean exactly? I think that means the top level thing that you're looking at. So it's like, it's a query, I think. Let response key. So I think this is query. Let group for response key be the list in grouped fields that for response key. Let group for response key be the list in grouped fields. Where does group field come from? Empty ordered map. Okay, so we've added group fields for response key if no such. Okay, I think I understand what's happening. Append all items in fragment group to group for response key. Okay, yeah, so we're just gonna, we've looked at our fragment, we're going to inspect it, and we're gonna say, oh, I have one for A. Okay, now I'm gonna add my definition for A to the list of things inside of grouped fields. So now we have an object that looks like it's like a key of A and a value of a list that contains this one element and then this one element. Okay, so we're going to do that. So let's say we go through the fragment. If selection is inline fragment, return group fields. Okay, and then we're back here. Okay, so now we have, all right, so we have like, it's just, this function is going to return a map of field names to selections of those selections on those field names. Cool. Okay, back to this. Let group field set, that object I just talked about, initialize result map to an empty ordered map for each grouped field set as response key and fields. So this is like A, and this is like the selection set on A. Let field name be the name of the first entry in fields. So that would be subfield 1. The name of the first entry field is known as value unaffected. Let field type be the return type defined for field name of object type. If field type is defined, let response value be, and then we're going to execute that field. Set response. And then we do that again. Set response value as the value for response key in result map. What is result map? Initialize empty ordered map for each. Don't we want to do this recursively? Group field set, execute field, execute selection step. What is this? Field name argument returns the result of complete value. After resolving, the value for a field is completed by ensuring it adheres to expected return type of the return type. Field execution. And then we do it recursively. Yeah. Okay, cool. Okay, so to execute a selection set, we're going to, I want to go back. How do we go back? We're going to do this, collect fields. Collect all the fields for an object collect all the fields for a selection set on an object into a map from field names to selection sets of the collect all the fields for a selection set on an object into a map from field names to selection sets. Sub selection sets. Then iterate over that map and resolve, execute what do they say exactly? Something about a value. Execute field. Complete value. Resolve value. Execute field. Resolve, execute the field. Produce a value. Every entry. For every entry in that map, resolve, execute the field, and produce a value. Produce a value. Sweet. Okay, I get it. Result map is ordered by which fields appear first in the operation. This is explained in greater detail in the field collection section below. Yep. Errors and non-null fields. If during execute selection set a field with a non-null field type raises a field error that then that error must propagate to this entire selection set, either resolving to null if allowed or further propagated to a parent field. If this occurs, any sibling fields which have not yet been executed or have not yet yielded a value may be canceled to avoid unnecessary work. If during a field with a non-null field type raises a field error, then that error must propagate to this entire selection set, either resolving to null if allowed or further propagated. Okay, so if I'm selecting a field that can't be null and it raises an error, then the whole selection above that field, the whole object above that, will also raise an error until we meet a point where the object we're trying to return can be null. And in that case, the error propagation will stop and return an error there and not return the value that you requested. So that is a way to ensure the types, the nullability of the types is respected. Yeah, okay. If a field marked as non-null produces an error, that field, the object containing that field, then the parent object, then the, error will propagate? How do we spell that? Propagate up to the parent object recursively until is an object that can be null. Yeah. Normal and serial execution. Okay, what the heck is that? Normally, the executor can execute the entries in a grouped field set in whatever order it chooses, normally in parallel, because the resolution of fields other than top-level mutation fields must always be side effect free and idempotent, other than top-level mutation fields. The execution order must not affect the result, and hence the service has the freedom to execute the field entries in whatever order it deems optimal. Sure. For example, given the following grouped field set to be executed normally, a valid GraphQL executor can resolve the 4 fields in whatever order it chooses. However, of course, birthday must be resolved before month, address before street. Yes. When executing a mutation, the selections in the topmost selection set will be executed in serial order, starting with the first appearing field textually. When executing a grouped field set serially, the executor must consider each entry from the grouped field set in the order provided in the provided in the grouped field set. Wait. When executing a grouped field set serially, the executor must consider each entry from the grouped field set in the order provided. Yeah. It must determine the corresponding entry in the result map for each item to completion before it continues on to the next. Sure. Must be serial. For example, given the following selection set to be executed serially, we're going to do this, and then we're going to do this. Oh, that's interesting. So what it's saying is it has to run this before and then this. But if we had multiple fields in here, it would resolve those fields in parallel. That's neat. I wonder what memory implications that has. As an illustrative example, let's assume we have a mutation called change the number, returns an object containing one field. The number, if we execute the following selection set serially, 1, 2, 1, 3, 2, we'll end up with 2, yep. Oh, that's really interesting. I guess you could do a mutation like that. I don't know why you would, but that's, yeah, you could. executing in parallel. Queries mutations must be run in parallel. Everything else can be, wait, serial, run parallel, run in parallel. Yeah, that's really just the gist of that. Field collection. Before execution, the selection set is converted to a grouped field set by calling collect fields. Yeah. Each entry in the grouped field set is a list of fields that share a response key. The value set defined, otherwise the field name. Each entry in the grouped field set is a list of fields that share a response key. Oh, I already read this. Nice. Do I want to talk about this anymore? I mean, can I make it any easier to understand? It's like deceptively simple. Maybe let's see. So we go through at each level of a thing, and we collect all of the selection sets for a particular field. And then we execute those, and then the results of those are bound to the response. So basically we look at this thing. Here's like our complete selection set. So, oh, we're looking at A, and we also are looking at A here. We're going to add subfield 1 to a list, or probably more accurately, this entire object that we're selecting, this entire selection set. We're going to add that to a list, then we're going to add this to a list, and we will execute those probably in parallel. And then we'll take the response and say, okay, look, we'll take this and we'll stick it on a response with a key of subfield 1, and take the result of this and stick it on a response with a key of subfield 2. And then you're done. I wonder what happens if this is called subfield 1. I guess it would just deduplicate it? Would it run it again? I don't know. For each selection and selection set, skip selection is a field response key selection. Group field response key if no such line. Append selection to the group. Interesting. Doesn't really say anything about skipping. Interesting. Each field requested in the grouped field set that is defined on the selected object type will result in an entry in the response. Each field execution first coerces any provided argument values, then resolves a value for the field, and finally completes that value by either recursively executing another selection set or coercing a scalar value. Yeah. Each field. Is this any different than the thing we have over here? Define this result in an entry and response map. Field execution first coerces any provided. So we coerce. Then resolve. Then complete by doing it over again. Yeah, I think that makes sense. Executing selection sets. I guess, is this even interesting to write down? I mean, it's sort of been covered. Executing selection, executing parallel. All right, sure. Executing fields. One. For each field, create a entry in the response map where the key is the field name or alias. 2. Coerce argument values. 3. Resolve field value. 4. Recursively execute inner selection set or coerce a scalar value. Fields may include arguments which are provided to the underlying runtime in order to correctly produce a value. These arguments are defined by the field in the type system to have a specific input type at each argument position in an operation. May be a literal value or a variable to be provided at runtime. What is the deal with coercion? Why is this interesting? Range argument definition, argument name, type value, has value, argument variable, has value be true, variable provides variable name, value provided by invariable name. So we're going to do some variable stuff here. Otherwise, let value be argument value. If has value is not true, default value exists. I think this is just like basic variable stuff. I don't think that's actually that interesting. Variable values are not coerced because they are expected to be coerced before executing the operation. Value resolution. While nearly all GraphQL execution can be described generically, ultimately, the internal system exposing the GraphQL interface must provide values. This is exposed by resolve field value, which produces a value for a given field on a type for a real value, which produces a value for a given type on a type, given field on a type for a real value. As an example, this might accept object type person, the field soulmate, the object value John Lennon, be expected to yield value Brazil Ono. I guess like our glossary is like I should really add that up here. Solver. The thing function that knows how to get. Oh, I think I know what they mean by initial value. Yeah, okay. So it's like the function that takes a parent object and a context and knows parent object, context, and a field name, and returns the value for the field on that parent object. And I think what they mean by initial value is like we need a resolver for like a query, where query is the top level object. And so like what should the parent object of that be? Okay, it could be like the initial object. Maybe that's what they mean. I don't know. Let resolver be the internal function provided by object type for determining resolve value. The result. Turn the result to calling resolver. Asynchronous due to relying on reading an underlying database, network service, necessitates rest of GraphQL executing handle. Okay, completion. After resolving value for field is completed by ensuring it adheres to the expected return type. Yes. Another object type the field executed recursively. Yeah. Primary purpose of value completion is to ensure that the values returned by field resolvables are valid according to GraphQL type system and a service schema. This dynamic type checking allows GraphQL to provide consistent guarantees about return time. Sure. Do we do type checking? See scalars along curves in some section more detail about how GraphQL both scalars. When completing a field with an abstract return type that is an interface or union return type, first the abstract type must be resolved to relevant object type. This determination is made by the internal system using whatever means appropriate. Common method for determining object type for an object values, use the class name. Okay, curious. Interesting how this, I am curious. I'm interested in how this works. Merging selection sets. When more than one field of the same name is executed in parallel, their selection sets are merged together when completing the value in order to continue execution of the sub-selection sets. An example operation, after resolving the value for me, these selection sets are merged together so that first name and last name can be resolved for one value. Interesting. So that's like if two selection sets are defined for a field of the same name, the field will be resolved, then these selection sets will be merged, and finally these merged select set will be executed. Cool, love that. That's really fun. Field errors are raised from a particular field during value resolution or coercion. These errors should be reported in the response. They are handled by producing a partial response. This is distinct from request errors, which are raised before execution begins. If a request error is encountered, execution does not begin, and no data is returned from the response. Okay, that's interesting. So we have a request error, which is an error produced by the Graphql system before request is attempted to be executed, and a field error is an error produced by the Graphql system during the resolution or coercion of a particular field. Cool, love it, interesting. Back down. If a field error is raised while resolving a field, it is handled as though the field returned null. Yep, and the error must be added to the errors list in the response. If the result of resolving a field is null, and that field is of type non-null, then a field error is raised. The error must be added to the errors. Sure. If some field errors are listed in the response, must be affected that is only one error should be added to the errors list per field. Since non-null field types cannot be null, field errors are propagated to be handled by the parent field. The list type wraps a non-null type, then one of the elements of the list, then the entire list must resolve to be null. Yep. If all fields from the root to the request are null objects, then the data entry in the response should be null. Yep. On to the response. When a GraphQL service receives a request, it must return a well-formed response. Yes, that would be nice. The service's response describes the result of executing the requested operation if successful and describes any errors. Yep. The response may contain both a partial response as well as any field errors in the case that a field error was raised on a field and was replaced with null. Sure. Describes a successful operation, any errors encountered, might contain a partial response along with errors encountered. Is a map. If the request raised errors, the response map must contain an entry with the key errors. That looks like this. So we have errors, which is the request completed without raising any errors. Something, we're not sure. If the request included execution, the response map must contain an entry with the key data. The value of this entry is describing the data section. If the request failed before execution, the entry must not be present. Only present if there are errors. Only present if the request executed successfully. And then we have extensions, which is what? If this entry, if set, must have a map as its value. This entry is reserved for implementers to extend the protocol. Is a map. Optional. Intended for devs. Extend protocol. To ensure future changes, the protocol do not break existing services. Client, the top level response map must not contain any entries other than the 3 described above. Yeah, okay. So basically, we have errors, data, and probably not extensions. Okay, what do we have in data? The data entry in the response will be the result of the execution of the requested operation. If the operation was a query, this output will be an object of the query root. The query root operation type. Query root operation type. If the operation was a mutation, this output will be an object of the mutation root operation type. Sure. If an error was raised before execution, an error was raised during execution, data entry in the response should be null. Yeah, okay. So, like, that's a map. Okay, errors. Errors entry response is a non-empty list of errors. Yep. Where each error is a map. If no errors are raised during the request, errors will be present in the result. If the data entry in response is not present, the errors entry in the response must not be empty. Sure. It must contain at least one error. The errors it contains should indicate why no data was able to be returned. Yep. If the data entry in the response is present, which includes if the data entry value is null, the errors entry in the response may contain any field errors that were raised during execution. Yeah, sure. Okay, so we have request errors raised before execution begins. This may occur due to a parse grammar. Request errors typically fall through requesting client. Request error is raised. Yep. Field errors raised during execution for a particular field. Internal error. Field will fall in the Graphql service. If you get a field error, execution attempts to continue and a partial result is produced. Yep. Error result format. Yeah, let's talk about data. Contains the response. Successful response. Output will be an object of type query root if operation was a query will be an object of type mutation root. Operation was a mutation. Errors. We have request error. Error parsing the request before execution. Probably the fault of the client. Think malform request. We have a field error. Error resolving a particular field. Probably the result of the service. Think record not found. Exception. Every error must contain an entry with the key message. Okay. So like error format. It's a map. The map. This is like a JSON. So we have to have a message. If an error can be associated to a particular point in the requested GraphQL document, it should be contained in an entry with the key locations. Keys in line and column where line If an error can be associated to a particular field in the GraphQL result, it must contain an entry with the key path. This is optional. It's a string. Describes the response. Field should be a list of path segments. Wait. This allows clients to identify whether this field should be a list of path segments starting at the root of the response and ending with the field associated with the error. Path segments that represent fields should be strings, and path segments that represent lists indices should be 0 indexed integers. If the error happens in an aliased field, the path to the error should use the alias name since it represents a path in the response, not in the request. For example, if fetching one of the friends' names fails in the following operations, we get a hero, name, hero friends, we get a list of friends. The response might look like we get an error, name for character, ID cannot be fetched. So we're going to hero friends, the first one. Grab the name. Don't think this is going to happen.
serialization format. Graphql does not require a specific serialization format. However, clients should use the serialization format that supports major primitives in the GraphQL response. In particular, the serialization format must at least support representations of the following primitives: map, list, string, and null. Serialization format should also support the following primitives: boolean, int, float, enum. Sure, we can have multiple. JSON is most common. Does not require a specific serialization format. When using JSON as a serialization graph, following JSON is used to encode. Yep. Serialized map ordering. Since the result, if evaluating a selection set, is ordered, the serialized map results preserve the order by writing the map entries in the same order. Serialization formats which represent an ordered map should preserve the order of requested fields. They represent order maps, but where order is still implicit in the serialization. Textual order should preserve the order. Yep. Sure. Order is important, but really, when you're using JSON, you shouldn't count on it. Oh, sweet. Okay, we're behind the index. All these are good. Do I really care about any of these? Grammar, semantic, algorithms. What is this? Grammar summary. Lexical tokens. What if I go here? Directives. Oh yeah, it takes me back. Okay, cool. We have an index? Oh yeah, that's neat. What about like a set? Is that in here? Selection set. Cool. That's fun. Well, that's it. That's the whole spec. Learned a lot. I will turn this into a gist. I'll clean it up probably and post it on the video description.